Okay, here's an example, or here's lesson 2.2b, integer exponents, which is very similar to the 2.2a lesson. The notes that we wrote about zeros, the exponent, and negative exponents are basically the same. So whatever you had from before is exactly the same this time. And for these, you're just going to notice that a lot of the bases are variables or include variables. So for number one, all right, we're talking about zero exponents for those. So k to the 0 power is just going to be 1. All right. Number two, you have the negative m in closed parentheses. So that means the entire thing is equal to 1. That's it. All right, it's pretty simple so far. Number three, we have -3 and then times q to the 0. Well, this part right there, that equals 1. So we really have -3 times 1. And I inserted the parentheses there myself. I mean, we could have wrote it down a lot of different ways. We could have written it as -3 times 1 like that. So I think sometimes it gets a little confusing. Like, why did I insert parentheses? Well, I'm just doing that just to imply that we're multiplying. We're using multiplication. All right, so the answer is -3, -3. All right, the directions for this next part, it says rewrite the expression with positive exponents, assume the variables do not equal 0. We're always going to assume that. And for this one, all right, we've got y to the -4 power. So if we imagine that as a fraction, and just like we said before, we're going to get rid of that negative exponent by changing its position, by moving it down. So that is what we're going to do. We're going to take that part and we're going to bring it down. Okay, and so it comes down to the denominator. If it was in the denominator, we would bring it up to the numerator. If it's in the numerator, we're going to bring it down to the denominator. So it just works that way. We're not always bringing something from top to bottom. It depends on where it is to begin with. If it's in the bottom, we move it to the top. If it's in the top, move it to the bottom. That's all there is to it. I know I'm kind of making it sound too simple, but that really is. It really is sometimes that easy. So you have 1 over y to the 4th right there. That's all you can do on that one. All right, number 5, we've got a negative exponent. We've got a fraction inside parentheses. So let's take care of that fraction by finding the reciprocal. Let's do that first. So we're going to do d over 3. And then by doing the reciprocal, that made the exponent that was outside the parentheses positive. So now we have 4, positive 4. And then now just apply that 4 to the d and to the 3. So we got d. So we have d to the 4th, and then we have 3 to the 4th. And then we can fix that up just a little bit more. D to the 4th, and then 3 to the 4th is 3 times 3 times 3 times 3, which is 81. Yeah, you guessed it. So you got 81 right there. And that's it. Okay. That's all we can do on that problem. Keep moving on here for number 6. For number 6, all right, it's important to note that when we move something on this one, now I know the 7 is right next to the f, but they're not totally married. You know, they don't have to stay together. We just have to move the parts that have the negative exponents. So that 7 can stay put. It's going to have to, because it does not have a negative exponent. If it had a negative exponent, it would look like this. It'd be 7 in the -1 and then f to the -7. But it's not written that way. It's not written that way. It's, you know, it's just 7. Or if you want to think a little bit more about it, it's 7 to the 1st power. Okay, so that 7 is going to stay where it is. We're going to move that f to the 7th down into the denominator. And that's it. So 7 over f to the 7th. So very important that when, I think sometimes when people see a negative exponent, they think everything's got to move. No, it's just parts that have negative exponents. That's what has to move, just that part. All right, number 7. What we have here is we have negative exponent in the numerator and the denominator. So all we have to do is flip it. And that will then undo the negative exponent part of it. So we'll do that. So the G goes upstairs, becomes G to the 5th. The F goes downstairs and just becomes F. I mean, if you want to put a 1 there, you can. It's not wrong though. But it's just not necessary. I mean, it was necessary when it was -1 because we wanted to show that it had a negative exponent. But when it's +1, we don't need to show that. We can just leave it off. We can leave it off. All right, number 8. Number 8 is just like number 6. All right, because on this one, we're just going to move, just like I've been focusing on here, we're just going to move the negative exponent. So we're going to move the S to the 10th power, negative 10th power, down to the denominator. So we're going to leave the 9 where it is. We're going to leave, oh, well, let's actually put this in alphabetical order. Let's do S to the 10th now. It's +10. And then T to the 4th, nothing happened to it, nothing changed. So it just stays where it is. So you got 9 over S to the 10th, T to the 4th. And that's number 8. Number 9. Okay, think of that. I always like to do that. I always like to write it so it looks like a fraction so that you know like where things are moving. You don't have to do that, but I just think sometimes it makes it a little bit more clear. All right, on this one right here, we're moving the C down to the denominator and we're moving the D down to the denominator. Okay, but we need something in the numerator. So everything leaves the numerator. And sometimes people think like, well, nothing's there. Well, something's there. We have to put a 1 there. We have to keep a 1. So we have a 1 in the numerator. And then we have a C squared D to the 7th in the denominator. All right, on number 10, I'm just going to, I'd like to kind of, you'll notice like I'd like to kind of outline what kind of almost like a football play or something. Like I'd like to kind of show where things are going to move to. Right? That's important. Kind of get a gameplay in order here before we actually start moving stuff. So we've got the B that's going to move down to the denominator, and the C is going to move up to the numerator. Okay, so then you've got, when we write all this out, we've got 7a squared. I should extend this a little bit. And then, using my eraser, C to the 4th. Okay, because that C moved down. And then down to the denominator, we've got a 6. And then the B moved. So you got B to the 5th. And I should have also pointed out that 6/7 right here, obviously, that 6/7 cannot reduce or simplify. I mean, I guess it could change into a mixed number, but I wouldn't go ahead and do that. I would just leave it improper. It's fine to leave it in ratio form. Perfectly acceptable. All right, number 11 has a fraction in parentheses and a negative exponent. So let's flip that fraction. That's your first thing you want to do. Flip it. Flip it. So now we got 2k on the top and we've got hm cubed on the bottom. And the exponent now is +5 because by taking the reciprocal, that undid the negative exponent part of it. All right, so now what we're going to do is we're going to take that 5 and we're going to apply that power of 5 to everything. So 2 to the 5th power, k to the 5th power, h to the 5th power. And then right here, we're doing power to a power. Right there, that's m cubed to the 5th power. So let's go ahead and just kind of write it all out. So we got 2 to the 5th power. We've got k to the 5th power. We've got h to the 5th power. And we have m to the 15th power. Okay? Because that was a power to a power. So we had to do, for that one, we had to do 3 times 5, not 3 plus 5. 3 plus 5. If it was 3 plus 5, it would have looked like this. It would have been like m to the 3rd times m to the 5th. In that example, that comes out to m to the 8th. All right, but if we have m to the third to the power of 5, that's a power to a power, and that equals 15, because the rule is when you have a power to a power powers mean that you have to multiply the exponents. 3 times 5. All right, and there's a little bit more I can do on this. Let's just simplify the 2. And 2 to the 5th power means 2 times 2 times 2 times 2 times 2, which is 32. 32, and everything else stays the way it was, as it was before. And this one's right as rain. Okay. All right, that does it for lesson 2.2b. I'll pick up 2.3 in another lesson.